In this video, let's begin by writing out some actual numbers. And we'll begin with a number that represents the circumference of the Earth, so the distance around the Earth around the equator. Okay? And this number begins with the number 4, and it's followed by 1, 2, 3, 4, 5, 6, 7 zeros. And this number has units of meters. So the circumference of the Earth is equal to 40 million meters. Okay, next we're going to write out another number in standard decimal notation. In this case, we're going to write out the width of an electron. So the width of one of these subatomic particles that we find whizzing around the nuclei of atoms. Okay, and what this number is it's a very small number. So we begin with a 0 and a decimal, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 zeros followed by a 2. And once again, this value is in units of meters. So we have a very small fraction of a meter that represents the width of an electron. Now the point of doing this is to show that these are big, unwieldy numbers to write on a page, right? They take up a lot of space and we wouldn't want to write them over and over again if we're doing a complicated calculation. So what we need is a more compact way to write very large and very small numbers. This is exactly what scientific notation is. Scientific notation communicates two key pieces of information about any number. The first important piece of information are the important non-zero digits of a number. In both of the values we wrote at the top of the page here, we have lots of zeros that are being used as placeholders. We would say that these are non-significant digits. In the case of the circumference of the Earth, we have 7 zeros to the left of the decimal place to show that this is a very large number. And in the width of the electron value, we have 13 zeros to the right of the decimal place to show exactly how small this number is. The second key piece of information is the order of magnitude of these numbers. Basically, we're going to do what those placeholder zeros were doing. We're going to show how large or small these numbers are, but we're going to do it without taking up quite so much space. And we can represent these orders of magnitude by raising the number 10 to different values of exponents. Before we write out some values in scientific notation, let's review some exponents of 10. Okay? First, we begin with the smallest exponent we can have, which is 0. 10 to the 0th power is actually equal to 1. Turns out that any number raised to the 0th power is equal to 1. Okay, this is probably the most tricky one. After this, we have 10 to the 1st power. You might remember that 10 to the 1st is equal to 10. 10 raised to the 2nd power is 100, a 1 followed by 2 zeros. And 10 raised to the 3rd power is 1,000, a 1 followed by 3 zeros. We can also see that carrying out mathematical operations with exponents of 10 is really easy because it basically just involves moving the decimal place. For example, if I were to multiply 5 times 10 raised to the 4th, that's the same thing as 5 times 10,000, which is the same thing as 50,000. All I did is add 4 zeros to the end of my 5. Because these exponents of 10 allow us to express orders of magnitude, this is the main tool that we will use when we write numbers out using scientific notation. On the right, we have a set of steps that we use to write numbers out in scientific notation, and we can follow these steps as we write out our circumference of the Earth value in scientific notation. We're going to begin by placing the decimal to the right of the first non-zero digit and dropping any leading or trailing zeros. Okay, well first our first non-zero digit is going to be the 4 here, okay? And if we just write down the number 4, there's an implied decimal to the right of that 4, and we're good to go. We don't have to write down the actual decimal point in this case. But we can also see that there are a bunch of trailing zeros here, zeros that are just there to show the order of magnitude of the number. And these are the zeros that we're going to drop. So we're good. We can move on to step 2, which is count the number of places that the decimal moved. Okay, our original value was 40 million, and we moved the decimal place 1, 2, 3, 4, 5, 6, 7 decimal places to the left in order to place that decimal next to that 4. Now we need to use the number of decimal places to set our exponent. our order of magnitude. So what we're going to do is we're going to multiply this value 4 times an order of magnitude written as an exponent of 10. Okay, because we moved the decimal place 7 places, we're going to multiply by 10 to the 7th. And there you go. The circumference of the Earth can be written as 4 times 10 to the 7th meters. The value is the same as what we originally wrote down at the top of the screen. Now we can also write the width of an electron in scientific notation, and the process is going to be pretty similar. However, there is one important difference. Because this number is really, really small, we're going to have to use negative exponents in order to express our order of magnitude. Now we can quickly review the negative exponents of 10 here. And if we start with 10 to the 0, that's still equal to 1. Now we have 10 raised to the negative first power. And this is an interesting result. Now we have 0.1. Okay, now we're moving the decimal point in the other direction. 10 to the negative 2 is equal to 0.01, and 10 to the negative third is equal to 0.001. Okay, the important thing to realize here is that we're moving the decimal in the other direction. Our orders of magnitude are making our values smaller. And when we're writing really small numbers in scientific notation, we're going to use values of 10 raised to negative exponents. Now we can use the same process to find our width of an electron value in scientific notation. So first we begin by placing the decimal to the right of the first non-zero digit, which is going to be our 2. So we can write down a 2 and have an implied decimal to the right of that 2. And then we're going to drop any trailing or leading zeros. So the 13 zeros that are only there to show the order of magnitude of the number, we're going to get rid of those to save space. Now we can count the number of places that we moved the decimal. In this case, we moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 places in order to get the decimal in its new position. And once again, we can use this count to set our exponent on our factor of 10. Only in this case, because we moved the decimal in the other direction to write this number in scientific notation, we're going to write a negative exponent. So we have 2 times 10 to the negative 14th meters. That's the width of an electron. Now there's one more point worth making in this video, which is that there is another form of mathematical notation that you might see, which is called engineering notation, and it's very closely related to scientific notation, except it's making the expression even more compact while containing the same information. What engineering notation does is it drops a multiplication symbol in front of the 10, and it drops the 10. So basically, you're only including the significant digits of the number and the exponent that represents the order of magnitude. And it replaces the multiplication symbol and the 10 using a capital or lowercase e. So we could equivalently express the circumference of the Earth as 4e7. This means 4 times 10 to the 7th. And we could express the width of an electron as 2e negative 14, or 2 times 10 to the negative 14th. Okay, with that, I think that's a good spot to end this video.